Architecture is one of the most interesting architectures when it comes to combining the images and the text. So as humans, we think using both modalities. We think using text, the language, and we also combine our language with what we see. As a result, it gives us a notion of multimodality in our brain. So up until this point, before the clip, there were language models and there were image models. Image models extract semantic information or information that is important to identify or classify, segment or detect objects. Image encoders extracted those image embeddings, and text encoders were specializing in extracting text embeddings. But what if we can combine both of these embeddings? So that is what clip encoder does. It maps the text embedding and the image embedding into a common space. So both the embeddings are living in the same space. And then they take the correlation between the embeddings. So we give the text encoder different sets of text, and we give the image encoder the corresponding images. And in the image text shared embedding space, the images and texts that are related must be mapped closer to each other. And as a result, we must define a correlation matrix. And this correlation matrix should be as close as possible to the identity matrix. So that is the training step. But what do we do when it comes to testing this or evaluating this? It is simple. So suppose you want to classify an image. So in general classification models, it is very simple, but here what we are doing is we give the image encoder the image, and then we give the text encoder a text like a photo of, and we give a space, and then we check all the possible text patches that can be placed in this slot we call object, and then we take which is highly correlated with the given image embedding. So that is it, and clip is very simple but very interesting, and thank you.